Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from CBSE 2025. Is it especially from the NCERT part 1, that means from electric charges and fields to the electromagnetic waves. Okay, and in this video we are going to solve the MCQ and case study questions of NCERT part 1. Why? Because there is no SSR region question from part 1, they was from part 2, and that we will cover in a next video. Okay, so let's start the video with the NCERT part 1 questions. Okay, so see here students, the first question is what? You can see the first question is a particle of mass m and charge q moving with velocity vi cap, that means along x direction, is subjected to a uniform electric field ej cap, that means along y direction. The particle will initially have a tendency to move in a circle of a radius. Is it? So here electric field is given and the charge particle is there. Which kind of charge particle? Positive charge particle. Okay. So remember that here what will happen, that the charge particle will move in a circular path. Okay. And that I am just doing here. Is it? So this circle path is there. And this charge particle is having the velocity in which direction? See here students. This is the velocity along y x direction, na? Vi cap here, is it? And here the charge is q and mass is m, is it? And electric field is acting in which direction? Electric field is acting in which direction? Along y direction, is it? So it should look just like along the center. Now let's take this is the center of the circle. For example, this is the center of the circle. Okay, so electric field along which direction? Along the y direction here, is it? So what will happen that here, you know very well, this is which kind of charge particle? Positive charge particle. It will experience force in which direction? In the direction of electric field, is it? That means what will happen that here, this charge particle will experience force in the direction of a electric field, is it? And you can see very well, angle between velocity and electrostatic force, how much here? 90 degree. So in this situation, actually the application is taken from the chapter moving charges and magnetism, is it? But anyhow, you can see here, velocity along x direction, electrostatic force along y direction, angle between them 90 degree. That means definitely work done by this force will be 0, speed will not change, and here in this situation the particle will move in a circular path here. Okay, and remember that here this electrostatic force will act as a centripetal force. So what we can write here students, remember that here this electrostatic force will act as a centripetal force. Electrostatic force formula we can tell Q into E. Centripetal force formula mv square by r. Okay, so when you will simplify this, what is coming? It is coming here r equal to mv square by qe. This is the radius of the circle, is it? But now this circle in a which plane? Because in the question they are asking. So you can see very well, the velocity is along the x direction. Okay, and you can see electrostatic force. This electrostatic force along which direction? Students, this electrostatic force is along y direction, is it? That means you can see this circle will be in a which plane? In a xy plane, in the plane of velocity and the electrostatic force. So what is the correct option? The correct option is here, option C is the answer, mv square by qe. In which plane? In xy plane. Single questions from electrostatics they have asked. Okay, next one, let's talk about here question from the current electricity based upon the Ohm's law. So see here, the figure shows the voltage versus the current graph for a wire at temperature T1 and T2. One can conclude that. So here you can see students, the graph is given, I versus V graph is there, is it? In the question they are telling voltage versus current, but the graph is which one? I versus V graph. And here you can see it is given the straight line, that means definitely they are talking about the conductors, is it? So remember that here one thing, here the temperatures are involved. So remember that for the conductors, you know very well, the resistivity of the conductor is directly proportional to temperature. I am talking about the ohmic conductor, okay, ideal conductors. And you know very well students here, this resistance is also given by rho L by A, or we can tell R is directly proportional to rho, is it? So hence we can write here from this one and this one, we can tell this resistance is directly proportional to temperature, is it? If the resistance of the wire is more, that means temperature is high. So remember that here, after that students, if I talk about here the Ohm's law. So according to the Ohm's law, this R is given by R equal to V by I, or we can write here tan theta. And what is tan theta? This tan theta is the slope of the graph. And whenever we are calculating the resistance, we have to see the angle always from the current. Is it? So see, this angle theta 1, this angle theta 2. Is it? So if I talk about here the angles, you can see very well, theta 2 is greater than theta 1, or I can write here, if I take both the sides, tan theta 2 is greater than tan theta 1, or I can write here, students, R2 is greater than R1. Is it? So as R2 is greater than R1 and the resistance is directly proportional to temperature, that means from this I can tell very well this T2 is greater than T1. Is it? The temperature, this T2 is more, T1 is less. That means which option is correct here? You can see very well. The correct option is here option D. Remember that for the resistance, we have to see the angle from the current, and for the conductance, we have to see the angle from the voltage. No? Because G equal to 1 by R. Is it? Great. Next one is, students, let's see here this question from the current electricity again. Question is, see, if Rs and Rp are the equivalent resistances of the N resistors, each of value R, in series and parallel combinations respectively, then the value of Rs minus Rp is how much here? So students, remember that here, if I talk about here the series, so for series connection, what is the formula used to be? Rs equal to R1 plus R2 dot dot dot. If n resistors are there, we can write here n times. But here remember that here identical resistors are there. They are having the resistance R. So we can write here in series combination, this Rs we can write here R plus R plus R. How many times? N times. So it will become here NR. Is it? Now similarly, if I talk about here the parallel connection. Okay, parallel connection. In parallel connections, what happens that here, remember that here 1 by Rp is equal to 1 by R1 plus 1 by R2 dot dot dot. Is it how many times? N times here, like 1 by Rn. Now, so if I talk about here, which kind of identical resistor. So in this situation, remember that here in a parallel combination, this Rp will become here R by N. Series means N into R. Parallel means R by N. Is it? By the same basic here. Now, so according to the questions, if I write here Rs minus Rp, what this will become here? Nr minus R by N. You can see R is a common outside, so N minus 1 by N. Just to simplify this, it will come here N square minus 1 by N, and that is our Rs minus Rp. Is it? So which option is correct here? You can see very well, students, the correct option is here option C is the answer. Okay, current electricity, second question even. Now see here the third question. And students, remember that here I have taken set 1, set 2, set 3, all the MCQ questions of the NCERT part 1. Okay, so see, the ratio of potential difference across AB in the circuit shown for the case, first case when the switch S is closed, and the second case when switch S is open. So students, here switch is there. Is it? So remember that here they are talking about here the potential differences across wire AB. Across wire AB, what is the resistance? 2R. Resistance is fixed. So remember that here when the switch is closed, let's take potential difference across AB is V1, and when the switch S is open, let's take V2. So when the switch closed, current I1, anyhow the resistance is 2R. When the switch is open, current I2, and here anyhow resistance is same 2R only. So 2R and 2R will cancel out. Is it? So what we can write here, see here, this V1 by V2, I can write here I1 by I2. So purely we have to take the ratio of the current, because anyhow the resistance will cancel out. Now students, remember that here what will happen when this switch S will close. So when the switch S will close, remember that here if I talk about here this one, this 4R and 2R in series means 6R. So when switch will be closed, what will happen? This 6R and 3R will come in parallel. Is it? So when they will come in parallel, what will happen that here, students, if I talk about here the equivalent of this, this one here, equivalent of this, switch is closed. So in this situation, what will happen that here, students, if I write here the R dash, you know the formula R1 R2 by R1 plus R2. So let's take R1 is the 6R, R2 is the 3R. So 6R into 3R by 6R plus 3R, that means 9R. So when you will simplify this, 6 into 3, 18R square by 9R. So it will become here 2R. Is it? So this equivalent is coming how much here? 2R. This is 2R and this is also 2R. That means total how much here? 4R. Is it? So remember that here when S is closed, how much current will flow here? I1 equal to, this is V, this is 2R, this is also coming 2R, that means what will come here students here, it will come here V by 4R, is it? This is when switch is closed. Now, after the students, when the switch S is open, what is happening that here, see, when S is open. So remember that here students, in the situation when the S is open, now what we have done here, when switch S is open, second situation. So there what will happen that, remember that here, there will be no current in this 3R. So if in case here current is I2, no current this side, so here also what will happen that here, current will flow I2. So you can see very well students here, this is 2R and this 6R, this 2R and this 6R will come in series because there is no current in this 3R. So when this 2R and 6R in series, how much equivalent? 8R, and this 8R will be connected across the voltage V, now across this terminal. So in this situation what will happen that here, this I2 is given by V by 8R, is it? Now according to the question, if I write here this V1 by V2, what is this here students? I1 by I2, is it? So what is I1? I1 is given by V by 4R, and this one how much is coming here students? V by 8R. So you can see here V by 4R into 8R by V. Just simplify this, it will come here 2 because 8 by 4 is 2 and others will cancel out. So which option is correct here students? The correct option is here option D is the answer, is it? Current electricity. Next one, let's see here. Again, one more questions from the current electricity. You can see multiple questions came from current electricity in the set 1, set 2, set 3 and all that, is it? So see this students. A wire of resistance R connected to an ideal battery consumes a power P. If the wire is gradually stretched to double its initial length and connected across the same battery, the power consumed will be how much? See here you can see here the same battery is there, and let's take the potential of the battery is V, is it? So students, first thing, remember that here, let's take this is the wire, no? And this is connected across the battery, no? This is connected across the battery V, no? This is the wire here, and resistance of the wire how much here? R, no? So you can see very well the power consumption will be how much here? P equal to V square by R, is it? After that what is happening that here, let's take this wire is elongated, no? Double its length. So remember that here students, when the wire will be elongated and connected across the battery, no? Connected across the battery, no? This one here. So you know very well students here we have to use the concept of the elongation, no? So what will happen that here, when the wire is elongated, this new resistance R dash is given by what here students? It is given by N square into R, no? If length of the wire is becoming N times after elongation, so what will come here? N square R. And how much elongated? You can see very well students here, stretched to double. So N value is the 2. So 2 square into R, it is coming here 4R. What is coming here students? R dash equal to 4R. This new resistance R dash equal to 4R. Is it? Now if I talk about here the new power consumption in this, is it? So it will come here V square by 4R. And you know very well students, this P equal to how much here? V square by R, is it? So V square by R will become P. So we can write here P dash is equal to P by 4. Which option is correct here? The correct option is here, option A is the answer. Is it? Great. Now students, let's move to the next one here. This question from moving charges and magnetism. Nearly we can see nearly 4 questions came from current electricity, is it? Now moving charges and magnetism. See, the value of magnetic field at point O in the given figure is how much here? Na? And this is very common question. Na? You have practiced this kind of question. So this question will be solved by the sections. This is section 1, this is section 2, this is section 3, is it? And remember that here, due to which sections magnetic field will be 0? Due to section 1 and section 3, students, what will happen that? The magnetic field will be 0. Why? Magnetic field will be 0 null vector, because observation point O is along the length of the wire, is it? Now, after that, if I talk about here due to section 2, the magnetic field is given by C. This is which coil? This is the semicircular coil. Directly formula is there. Remember that here the formula mu naught I by 4R. Standard formula is this, mu naught I by 4R. In which direction? All the fingers along the current, palm towards the observation point, thumb is going inside. So students, we can write here minus K cap, is it? So if I talk about here the net magnetic field is given by B naught 1, now because magnetic field is a which quantity students? A vector quantity. Now, so what this will happen that here? Anyhow, this B naught 1 is 0, B naught 3 is 0, only B naught 2 is there, is it? So students, we can write here this B naught means B naught 2 only, and what is this mu naught I by 4R, is it? And minus K cap. If we talk about here only magnitude, which option is correct here? You can see very well students mu naught I by 4R, the option is option C, is it? Great. Next one again, question from the moving charges and magnetism, actually the conversion from galvanometer to the voltmeter, is it? Let's see the question. See, a galvanometer can be converted into an ammeter of desired range by connecting a. So remember that here students, here whenever one galvanometer is there and I want to connect it to the ammeter. So in this situation, what will happen that here, this is the galvanometer, we have to connect one small resistance or low resistance in parallel, that is called here the R shunt. Now current I will come here, full scale deflection current Ig, and here how much current will go? I minus Ig. So whenever we are converting galvanometer to the ammeter, we have to connect one small or low resistance in a parallel, is it? So correct option is here option C. And for the information purpose, if galvanometer is going to convert into the voltmeter, that time what we have to do, we have to students connect one high resistance in series, is it? And it used to be like this here, is it? This used to be the RS, here galvanometer like this, and here the current Ig will be there. So galvanometer to ammeter, low resistance in parallel called shunt, and galvanometer to the voltmeter, high resistance series, is it? So remember that here. So anyhow, very simple question, easy question. No? Next one students, let's go to this question. Again, moving charges and magnetism. Too much weightage. See here, a proton and alpha particle enter with the same velocity. Keyword is the same velocity, okay? V in a uniform magnetic field B such that V perpendicular to B, the ratio of radii of their circular path is how much? So anyhow, remember that here, that means when V is perpendicular to B, that means when theta is 90 degree, which path will be there, students? The path will be circular path, okay? And in this situation, when the path will be circle, na? So see here students, the path will be which one? Circular path will be there, na? So see here, I'll draw here a circle, like this kind of circle will be there, okay? And here let's take, for example students, here what is happening? Velocity let's take in this direction, is it? So velocity in this direction, magnetic field inside, so one force will act here, that is called the magnetic force. Now I'm telling the basic, this magnetic force will act as a centripetal force, okay? So students, when this magnetic force will act as a centripetal force for the circular motion, is it? So here what will happen that here, students, remember that here, I'm just very basic, na? So I'm not writing the formula directly. Fm means it is given by QVB sin 90, na, circular path here. Centripetal force mv square by r. So when you will simplify this, r will come here mv by bq, is it? And you know very well students here, the same velocity is this magnetic field is also uniform. So remember that here, this r is directly proportional to m by q, is it? And here they are talking about the which particle? They are talking about the proton and alpha particle, okay? So students, for remember that here, proton, deuteron and alpha particle. Alpha particle, even we used to write here He plus 2, double ionized helium ion, is it? So if the mass is m, 2m, 4m, like this. If the proton is having mass m, deuteron 2m, alpha particle 4m. Charge means E2E, is it students? So this thing you have to remember that here. Now after that here, based upon the question, if I write here R proton by alpha particle, it will be m proton by m alpha particle into q alpha particle by q proton, is it? Now students, just put the value here, m proton, what will happen that here, students? See, m by alpha 4m, charge on alpha particle 2e by e, is it? So when you will simplify this, e cancel, cancel, 2 by 4 means how much here, students? Here 1 by 2. Which option 1 by 2? Option B is the correct answer, is it? Great. Next students, let's move to this question. The question is what? From the moving charges and magnetism, force based question. See, a straight conductor is carrying a current of 2 ampere in which direction? In positive x direction. A uniform magnetic field, this one, is switched on in the region. The force acting on 10 centimeter length of the conductor is how much here? Okay, so remember that here, students, here the force formula is given by F equal to I L cross B, is it? Even if I multiply I also inside, so we can write here I L cross B, is it? And this is called what? This is called the current element, and this is always along the direction of the current. Current is flowing in which direction? Positive x direction. That means current element in which direction? positive x direction. Okay, students, so let's put here the values and all that. Current how much is given here, students? 2, is it? And length how much is given here? Length 10 centimeter. That means 10 centimeter means we can write here 10 into 10 power minus 2 meter. That means 10 power minus 1 meter, is it? So students, I can write here, see, 10 to the power minus 1 meter. In which direction? Positive x direction. Unit vector I cap, is it? Cross. Magnetic field how much is given here, students? Kindly see here 0.6 j cap plus 0.8 k cap. Now here we can do the cross product by the determinant method also, but not required. Now directly we'll do here. So what will happen here to the students? Just multiply here 2 into 10 power minus 1 into 0.6. So students, it will come here this and this multiplication, it will come here 0.12 and here I cap cross j cap, is it? Plus again 2 into 10 power minus 1 and we have to multiply with 0.8, it will come here 0.16 and it will come here, see, I cap cross k cap, because I cap is coming first, so I cap cross k cap. Now, so what will happen here? See, 0.12 I cap cross j cap means k cap plus 0.16 I cap cross k cap is minus j cap, no? Minus j cap, is it? So here what will happen here to the students when you will simplify this here? Anyhow, minus 0.16 j cap plus 0.12 k cap, unit is Newton. Which option is correct here? You can say very well, students. The correct option is here, option B is the answer, is it? So very basic kind of questions came. Now, next one, students, let's see here. Here the question is from magnetism and matter. What is the question? See, a piece of diamagnetic material free to move when placed in uniform magnetic field. Which kind of field is given here, students? Uniform magnetic field here. Okay, so here they are telling what is, students? Uniform magnetic field. Okay, so to solve this question, first we have to understand very well how this diamagnetic substance will behave in non-uniform magnetic field. Okay, so remember that here, students, here whenever magnetic field is there and you are keeping one diamagnetic substance, is it? So let's take for example in this direction, students, one magnetic field is there, external magnetic field. Okay, so what will happen that here you have kept one diamagnetic substance, is it? So the diamagnetic substance will induce one magnetic field in the opposite direction of the existing magnetic field. Now, this is the external magnetic field and this is what the magnetic field is coming because of this diamagnetic material, is it? So because of that, what will happen that here, students, here this if I talk about here this resultant magnetic field, vector B equal to B naught plus Bm. So what used to be there? Remember that here in this situation, this resultant magnetic field inside the material is used to be the less than the external magnetic field. Why? Because Bm in which direction? Opposite direction. So because of this nature, what will happen that here when a diamagnetic substance is placed in a non-uniform magnetic field, it is having the tendency to move from stronger magnetic field. Where to the students? From stronger magnetic field towards stronger magnetic field to weaker magnetic field side. Okay, weaker magnetic field side here, is it? This is about the dia, is it? In case of para, you know what will happen that here this Bm will come in the same direction, is it? In the same direction of B naught, and paramagnetic substance will be having the tendency to move from weaker magnetic field to the stronger magnetic field, is it? If I talk about the ferro, you know this Bm will be in the direction of B naught and Bm will be more than B naught for the ferro. In this situation, you know what will happen that the ferromagnetic substance will having the tendency to very strongly move from weaker magnetic field to the stronger magnetic field. All these things I am telling where? For the non-uniform magnetic field. Why? Because to understand uniform magnetic field, we need this. Now students, if I talk about here for the uniform magnetic field, you know here what will happen that here, students, here uniform magnetic field, here no stronger magnetic field side, no weaker magnetic field side, is it? So there will not be any tendency developed. Why? Because in a uniform magnetic field, net force acting on the diamagnetic substance will be how much here? 0, and that means it will does not move at all, is it? So correct option is here, option D, is it? Very basic thing. To understand this, first we know this, is it? Now students, see the next one here. The question is what here, students? a vertically held bar magnet is dropped along the axis of a copper ring having a cut as shown in diagram. The acceleration of the falling magnet is how much here? Okay, students. So here what is this? Remember that here is a one coil is there like this here. In a question they have given like this, is it? And one bar magnet is falling like this here. No? One bar magnet is falling like this. Let's take this is north pole, this is south pole here, and this is falling. Now this is given in a question. So you know very well, students here, you know very well, when the bar magnet will fall, what will happen that here? During the falling, this magnetic flux linking with the coil will change, is it? Anyhow here it will increase, is it? So because of that, what will happen that here? EMF will induce in a circuit. Na? EMF will induce. EMF can induce in open circuit also, closed circuit also, no problem. But do you think that is there any induced current in this? No. Why? Because this is which one, students here? Open circuit. That means there will not be induced current. As there is no induced current means there is no Lenz law. No? There is no Lenz law. What is the Lenz law? Lenz law means it always opposes the cause. No? So there is no opposition of the cause. The magnet is falling downward. There is no opposition. So if in case it is falling with gravity G, there is no opposition from the Lenz law because there is no induced current. So anyhow, the magnet will fall as it is. So remember that here, if in case the circuit is open circuit, the A will be G only, is it? But if in case the circuit is the closed. So in this situation, opposition will be there. I'm just telling for the example. That means if the magnet is falling downward, it will oppose upward. Similarly, after crossing this ring, if the magnet is going downward, it will attract towards upward. That means in all this situation, what will happen that here? This A will be less than G. So open circuit, A equal to G, closed circuit, A less than G. Which option is correct here? It is the cut is there, open circuit is there. The correct option is here. Option C is the answer. Is it? Great. Now students, after that, see here this question. The question is what? From the alternating current. See, an AC source is connected to a resistor and an inductor in series. The voltage across the resistor and inductor are 8 volt and 6 volt respectively. The voltage of the source is how much here? Okay. So students, here they are not talking about which kind of voltage. So if they are not talking about anything, this is the RMS voltage. So across the resistance 8 volt and across the inductor how much is given here? 6 volt. Which voltages are there, students here? They are the RMS voltage. Okay. So remember that here, if in case this is the resistance and this is the inductor connected in series across the AC V. Okay. So here what is happened? Let's take the voltage drop across the resistance is R and across the inductor is L. So remember that here, students, as R and L is connected in series, so the current will be same in both of them, is it? Now after that, at any instant the current will be same, is it? Now remember that here in case of R, what will be there, students? Here the I and voltage drop across R will be in a same phase. But in case of inductor, what will be there? The current will lag from the voltage by 90 degree, is it? So here VL will be in this direction, is it? So if I combine both of them, so what will happen that here? See the students here, this is I, is it? And VR in this direction, all RMS, is it? And this VL in this direction. Just make here the parallelogram here, and this is the supply voltage V, is it? So students, in this, if I use here the Pythagoras theorem, so what we can write here? V equal to square root of VR square plus VL square here, is it? Now let's see here the question and all. So 8 square plus 6 square, it will come what is square root of 100? That means 10 volt, is it? And which option is correct here? The correct option is here option A anyhow, okay. But remember that here in this situation, for the RMS voltage, what will be there, students? This KVL will not be valid, okay. If we talk about here the instantaneous voltage, which voltage here, students? Instantaneous voltage, V equal to VR plus VL. In this situation only, what will be there? The KVL will be valid, okay. So KVL is valid for the instantaneous voltage and the KVL is not valid for the RMS. Nothing is mentioned RMS voltage. So we have done that like this, and the correct option is here. Option A is the answer. Is it, students? So these 12 questions came in the NCERT Part 1. So many questions from current, electricity and moving charges and magnetism. And if I talk about set 1, set 2 and set 3. So in all the sets, AR questions was same from the second part only. Case study was also same in all the 3 sets. One case study from the potential and capacitance that we are going to see, and one more case study came from NCERT Part 2 semiconductors that we will cover in the next video, okay. And one more interesting thing was there, in each and every set, the 3 MCQs was different, is it? So total 12 MCQs was there. So in 3 MCQs in each and every sets was different. Other 9 MCQs was common. Okay. So students, after that we are going to move here for the CBQ question. Now, so see here CBQ of CBSE 2025 potential and capacitance. Here some what to tell, they have given some information. Even you can read by yourself to solve the question. This is just general data, is it? Just you can read by yourself. It will not be required that much in the question solving, but you can read it one time. Okay. So this is one thing. And again you can see here also students, some general data is there, you can read it by yourself. Okay, just normal information is given here, is it? So you can read it one time. Now students, based upon that, if we talk about the question, question is here. See how to solve the question. The first question, see, consider a capacitor of capacitance C with plate area A and plate separation D filled with air. This is the figure A, is it? Now students, the distance between the plates is increased to 2D and one of the plates is shifted as shown in figure B. This is figure B. So now the capacitance of the new system is how much here? Okay. So students, remember that here if I talk about here the case A. So in this situation only what is present here? Air, is it? So in this situation this plate area A, this is also anyhow plate area is A, total this one here, common plate area A for both of them. Now, so what will happen that you see here the capacitance is given here, the students, C equal to epsilon naught A by D, is it? For first situation. Second situation for B, remember that here the students, what is given here? Let's take the new capacitance is C dash. But here what happened that here this plate is shifted upward. So in this situation we have to see what is the common interface or common area for the plate. So as you can see very well, the half of the plate went upward. So this area will be how much here, students? Here this A by 2. Here A by 2, this is A by 2. Common interface we have to see. Distance how much here? 2D. So here what will happen that you see the students, say epsilon naught. This is the common area A by 2 and this distance is 2D. So when I will simplify this, it is coming here 1 by 4 epsilon naught A by D. And what is epsilon naught A by D? C, that means we can write here C dash equal to C by 4 here. Is it? Always remember that here we have to see the common area. Here also this A, common interface A. But here A by 2, this is also A by 2, common interface A by 2. Is it? So which option is correct here? The correct option is here. Option A is the answer. Is it? Little bit tricky question from the NEET and JEE concept. Next one is students here. The second question. See, a slab area A and thickness D1 of linear dielectric of dielectric constant K is inserted between charge plates, charge density sigma, of a parallel plate capacitor, plate area A and plate separation D. And here this D1 length is less than D. Now, and opposite charges with charge density of magnitude sigma P appear on the faces of the slab. The dielectric constant K is given by how much here? Okay, students. So remember that here, if I talk about here initially, if there is the no dielectric, here sigma and here minus sigma and here only what is present? Air is present. And here electric field how much here? Here electric field is E naught. Is it? Now students, in second situation what is happening that here? Let's take here this is sigma, this is minus sigma. Linear dielectric. So here what will happen that here one charge will induce here minus sigma P and here charge will induce plus sigma P. Okay, so because of that, you students, you know what will happen that here, as you know very well, electric field due to the charge on the plates is E naught, but because of this induced charge, there will be the one electric field in opposite direction, that is called E induced here. Okay, this is the two separate diagrams here now. So students, remember that here when the dielectric will be induced here, this resultant electric field is given by what? Let's take here anyhow, this side plus, this side minus. Now no need of vector sign and all that. So students, remember that here this will come here E equal to E naught minus E induced. Okay, and normally electric field will decrease, so we used to write here E naught by K. What is K? K is the dielectric constant. Now we are going to see this one here. So students, you know very well this E naught is given by E naught due to sigma. So sigma by epsilon naught minus E induced how much here, students? This induced is coming because of sigma P. No? So sigma P by epsilon naught, is it? Equal to 1 by K, and anyhow E naught value how much here, students? Here the sigma by epsilon naught. Is it, students? So you can see very well sigma by epsilon naught and all. Now epsilon naught will cancel out. Is it? So what we can write here, students, here from here, if I write here, see the students, we can write here, see sigma No? What will come here? See here students, this sigma minus sigma p, because epsilon naught is cancelled, is equal to sigma by k. So sigma minus sigma p equal to sigma by k. So from here students, if I write here the k value will come here sigma by sigma minus sigma p. Which option is correct here? The correct option is here option B. Remember that for the air and all, the k value will be 1, but for any other dielectric, k value will be greater than 1, and for the conductors, the k value will be infinite. Is it? Very basic thing is there. Okay, great. Now students, let's move to the next question here. This is a direct question. What is the question? See, an electric field is established between the plates of an air-filled parallel plate capacitor with charge Q and minus Q. Now, one plate having charge plus Q and the plate is having charge minus Q, two plates involved. That you will get in a data of the case study. V is the volume of the space enclosed between the plates. The energy stored in the capacitor is how much here? Okay, students. So remember that here the energy stored in a capacitor, the formula itself you should remember, half CV square, or maybe Q square by 2C, or maybe half QV, and one more formula is there, energy density into volume. So energy density how much here? Half epsilon naught E square into volume. Is it? So if you will check out here students, the correct option is here option C is the answer. No? Direct question, no calculation and all that. Okay, great. Now students, let's move to this question here. No? See this question, see. Actually, this fourth question came optional. Either you attempt A or you attempt B. Here I am solving both the questions. Okay, so see here. 3 capacitors A, B and M, each of capacitance C. A, B and M, each of capacitance how much here? This is also C, this is also C, this is also C. 2A are connected to a capacitor N of capacitance 2C. Here capacitance 2C. And a battery as shown in figure. If the charge on A and N, on A is Q and on N Q dash respectively, then Q dash by Q how much here? Okay. So remember that here on A how much charge is there? They are telling Q charge. Here Q charge is coming. And on N how much charge is here students? Here the charge is a Q dash. Is it? So here what will happen that here? Students kindly remember that here on N directly you can see students here the potential difference is V. Is it? So here we can tell here students here this charge Q dash is given by, is it? This Q equal to CV. No? So this is 2C and potential is V. Is it? After that students, please remember that. No? You can see very well here. No? See, this is the 2C. But now this C, this C, this C connected in a series. So here what will come here students? This will come here C by 3. Is it? And here anyhow the battery V is connected. Is it students? So here what will happen that here students? In this situation, the charge Q. So charge on this capacitor will be how much here? Anyhow we can write here C by 3 into V. And you know very well whatever charge on a equivalent capacitor, same charge will be on the individual capacitor also. Like here also it will be Q, here also Q, here also Q, and here also any how much here? Q. Is it? So what this will come here students is C by 3 into V. Is it? So if I divide here see students this Q dash by Q, what will come here? This Q dash by Q students just see here. Q dash will come here see 2CV by, we can write here see CV by 3. So CV cancel, it will come here 2 into 3. How much is coming here students? 6. Which option is correct here? The correct option is here option D is the answer. Okay, is it? Now students, after that the last question is left. No? This is students also will see that here optional question we are solving. No? Optional question. So see the students, the question is a slab area A and thickness T by 2 of dielectric constant K is inserted in parallel plate capacitor of plate area A and plate separation D. If C and C naught are the capacitance of the capacitors with and without the dielectric, then C by C naught is how much here? Okay. So students, according to the question, C naught is without dielectric. Okay. So without dielectric, what we can write here? It is given by C naught means epsilon naught A by D. Is it? After that, remember that here, let's take charge Q minus Q connected to the battery, and here students what is given here? This thickness is D by 2, and here how much is this? D. So in this situation students, what is the new capacitance? The formula is, remember that here, epsilon naught A by D minus T plus T by K. Is it? So we can write here see epsilon naught A by D minus T. How much is given here? D by 2. Is it? Plus again here D by 2K. So students, this d minus d by 2 will become here d by 2. So we can write as C equal to epsilon naught A. D minus d by 2, as I have told you, d by 2 is it? So see here d by 2 plus d by 2k. Now students, so see here epsilon naught A by, I have taken here d by 2 outside common. So it will become here, see students, 1 plus 1 by k. Is it? Now you can see students here, what is the epsilon naught A by d is the C naught, is it? So here I can write here, kindly see here, this C equal to C naught by 1 plus 1 by k, and here 1 by 2. Is it, students? So when I will take here the ratio C by C naught, just simplify this, it will come here 2k by k plus 1. What is coming? 2k by k plus 1. Option B is the answer. Okay. So students, I hope so this MCQ questions, some nearly 12 MCQs are there, and this 5 case based questions is very clear to you from the NCERT part 1. So I hope so this video is very informative to you. You will learn something from this video and you will use in the next year. So students, keep studying, keep growing.